Hello, welcome to my channel. In this video, we are going to discuss the topic bandpass filter, and this bandpass filter can be Chebyshev or Butterworth filters, and we are going to use parallel coupled lines to implement the filter. The procedure is pretty straightforward. The theory might be a little bit complicated, but for the time being, we can bypass those complicated theories first. So this is the typical layout of a bandpass filter, and you can see in this example we have 1, 2, 3, 4, 5. We have 5 stages, and each stages is implemented with a coupled lines, the parallel coupled lines. And the entry and the exits are highlighted in the green circle here, and this is so-called inputs and output ports. The procedures for implementing a bandpass filter is quite straightforward. The very first thing that we need is to find out the order of the filter, and if the filter type is Chebyshev filters, then the order n should be an odd number. The next thing that we are going to determine is the fractional bandwidth. And the next step is to use the prototype tables to obtain the G values. I think the G values are so-called emittance, I think. And then with the G values, we can calculate the inversion capacitance. Inversion impedance, J of Z. Each stage itself has its own value of JZ. The formulas are given here. The start stage and the end stage has a formula like this. The formula should be very similar. The middle stage, each of the middle stages should be calculated with this formula. And with the J of Z value, and we should be able to calculate the utmost impedance and evenmost impedance for each of the stages. The formula that we need is this one, and this one is given for the evenmost impedance, and that one. This one is to be used for calculating the utmost impedance. So the formula should be very easy to remember. The top one here has a plus sign in the middle terms. The utmost impedance has the middle terms associated with the minus sign. So let's take a look in an example. We are going to implement a bandpass filter. The filter type that we want is a Chebyshev, and the bandpass ripples should be less than 0.5 dB. The order of the filter is free. So in this case, we should have 4 stages. The bandwidth is 10%, and the resonant frequency is 2 gigahertz. So I'm going to write down the detail first. N is equal to 3. The fractional bandwidth is 0.1, and F0 is equal to 2 gigahertz, and type is apertures with passband. Okay. So now we are going to implement this filter. The very first thing we need to pay attention to is the order of the filter, 3. And with this in mind, we should be able to calculate the we should be able to use the prototype table to find out the emittance, and from there, according to the table, G0 is equal to 1, G1 is equal to 1.5963, and G2 is equal to 1.67, and G3 is equal to 1.6963, and obviously the last value G4 should be 1. So this is what we have got. So the next thing that we are going to do is to work out the phase Z value. Each stage has its inversion impedance. So we are going to do it for each stage. And this one, according to the formula, is given by G1. And according to what we are given, the fractional bandwidth here is 0.1. So we just substitute this directly into the formula, and 2G1, G1 is given, right? So 2 and then 1. Sorry, it should be 1.5, it should be 1.563, yeah, sorry. So if you do it carefully, you should be able to end up with an answer V1, V7. Okay, the next thing is to calculate J to Z. And the formula that we need is and with this in mind, and we get 0.1, 2, G1 is this value, and G2. And if you do it carefully, you should end up with a value 0.1187. And we should continue with this process for all stages. So stage 3 have this inversion in impedance, and we should do this. The formula should be similar to what we have for stage 2, and this will be stage 3. So from what I have got here is by 0.1, and then 1.967, and G3 is 1.63, and if you do it carefully, you will end up with the same figure. Yeah, same as before. Yeah. So finally, we are going to work out the JZ value for the last stage. And what we have got here is we should use the formula similar to this one, but the bottom value should be square root of the last two values, G3 and G4. So again, we should do this. And then 1 point, and then this one, yeah, and then you should end up with the figure like this. So these are the JZ value for each stage. So with this in mind, we should be able to work out the even mode and odd mode impedance. So the next stage is for me to work out the okay, so we, from the previous exercise, we have already calculated JZ value, yeah, it is 0.3137, and then V10, which is equals to 1187, and this one is the same, and this one is should be similar. There's something wrong here. Yeah, it should be 1, and then 2, and then 3, and then 4. Sorry. In this case, here you get 0.137. Okay. So I should say this. This is stage 1, 2, 3, 4. So this is the table we've got, and this is the J E0 value. And now the even mode impedance E0, and we are going to calculate this. And according to our calculation, we should use the formula this one to calculate this the value for each stage in this column. 1 plus J Z0, and then J Z0 square. So this is the value that we need to use. If you do it carefully, let me see if I can take out the value. We need to calculate this. So according to my calculation, we got 7.60, and this one is 7.60, and this one is 56.64 and 56.64, and we can do the same for the utmost impedance. We have to use this formula. And if we do it carefully, we should end up with 39.24. So I hope this will help. This is what we need for implementing a filter. And you will want to know how the filters look like. It will be like this. So in stage 1, we will have a couple like this. In stage 2, we will have another coupled line like this, and in this case it will be this one is Z0 E1 E0 1, and this one is E0 E2 no 2. So we will continue with this process. And this is what you expect. And this one is E0 E3 no 3, and this one is 4 and 4, and the length for each stage here should be calculated using the formula here. Lambda G divided by 4. And then the frequency, which is 2 gigahertz, and then divided by the 4. So you the value is 0.5 centimeter. Yeah, 37.5 centimeter. So if you have any issue, any question, please leave your questions to the comment section of this video. Thank you for your time.